Hello, Titan dev team and everyone else watching sneakily in the background. We're going to be doing another session today, but before we kick it off, as always, a thanks to our current partners, Perforce and AWS, who have banded together to help make this project possible. As always, big thanks to those two excellent companies helping us out. So we are going to be taking a big look into how we built the landscape for Project Titan. And it was a bit of a challenge. Main reason being because Project Titan happens to be on quite a large map. It's about 8 kilometers by 8 kilometers. And once you get past, I'd say maybe 2 kilometers out in either direction, you start to run into some weird stuff. Now, one of the cool things about Unreal is that as of UE5, we moved over to large world coordinates, which means that we can get much bigger. But even with large world coordinates, there's still a lot of considerations that we have to keep in mind. Now, before we get into the landscape design tools, it's always worth having a little fly around the Titan game world. So if we bring up my screen, we can have a look at some of the awesome stuff that's being posted. We are now in week 4? I feel like we're in week 4. Oh my God.
We're indeed in week 4.
Slightly terrifying how quickly this is going. But we've had some absolutely incredible stuff come through. So a couple of pieces. I think this one is Ren, who is absolutely prolific in asset creation at the moment. It's got these absolutely amazing kind of vines coming up. They've gone through a few different iterations and been brought through, but they have a real nice character to them and some lovely shapes as well. So some really nice stuff. And continuing on, also the same artist, I think, though they might have collaborated on this one a little bit. We have these lovely kind of Hobbit-esque houses in this little kind of little glade tucked away.
Love these.
Yeah, these are absolutely stunning. So some really nice stuff going on here. Really looking forward to seeing how these progress further forward. The village near the kind of the large observatory-esque building. I don't know what it is at the moment, but I'm looking forward to seeing what it turns into. It's absolutely incredible. These houses, again, I still love how these are progressing. Some really lovely stuff, but now it's been really expanded out into this really nice kind of little farm village area over here, and really kind of start to be kind of just developed out a little bit more. So some really nice stuff going on here. Volcanic has had an explosion. Get the
Yeah.
pun.
I was laughing on the inside.
I'm so sorry. Has had an explosion of content over the last week or so. It's really starting to get fleshed out. Some really nice stuff being developed. You know, kind of the lava streaming down is really nice. They've started to adapt the actual water tools. So I think we will be able to walk ride these, which is going to be really fun. Fun thing to do, and making it so that the character doesn't look like they're burning in lava is going to be quite difficult. But anyway, some really nice stuff here. These buildings have got some nice character to them as well, so it's interesting seeing those develop. So some great work happening in Volcanic. Some really nice stuff happening in the Arctic as well. These kind of little kind of glaciers and kind of little pools of snow are really starting to come together. I don't know if you've seen in here, Sam, but there's some cool stuff going on in here as well, with these lovely little houses.
I love those.
That have got some real great character to them. The little shell roof tiles is a really nice idea. These little coral extras are really good. Missing an interior, but that's fine. I'm sure they'll work.
That's
on those
really nice shape.
And then there's this little I didn't even know this was here, but there's a little kind of hidden city even tucked away as well, with some stuff going on there. So some really cool things. Honestly, it's amazing, like all the little nooks and crannies where you just completely miss this stuff. The clifftop team, I think, probably one of the best iterators on their content in the group. Absolutely amazing. Every time we give them feedback, they go back and they make changes and they really take it on board. It's absolutely, kind of one of the best ethoses I've seen with this stuff. And it's so important that you really go in, you iterate on content, every piece that you make is going to be better. We've now got a much better read on this tower, whereas before it was this little teeny weeny little tower tucked away in the corner. Now we've got this really grand area, really clear entranceway coming in, which is nice. I think I've even seen some stairs of a reasonable size as well, which is really cool to see.
We love a reasonably sized stair.
I
really
love a
does
reasonably
help.
sized stair. It's one of the, it really makes my day. So yeah, some really good stuff going on there. Absolutely keep that up. That's doing really nicely. The Arctic, the desert region is really starting to get some character now. Really happy with how that's progressing. We've got these lovely palm trees, which I again found while I was having a little bit of an explore. They are really nice. They've got some really nice like kind of meat to them. They're really chunky. So some really nice stuff there, and this little glade area is just really nice as well. Great overhanging on the rocks as well. So really kind of like pulling out that geometry. They have definitely watched that accentuating the landscape video that we posted a little while ago. So some really nice stuff there. And also, I've just got to call out the night market again. Looking really nice. This lovely kind of central mushroom has just got so much character to it. It's so much, kind of real, just lovely shapes to all of it. And same with these really nice little things. So I think you had some design crit for them on these ones. Only thing I will say is that I'm fairly sure each of these planks is an individual instance. So it might be worth going in and just building some more block shapes for those. But otherwise, some really lovely stuff going on there. We've also seen in the kind of like the area where it's starting to blend together, this little carnival, kind of area open up. This is, kind of really one of the things I love about this is that they're really taking use of all of the assets that are being made for Titan, right? So anything that's made in Titan, we can use, kind of all over the place. So they've really started to kind of like find assets that, kind of they like and are working well, and really starting to kind of assemble their own space using a lot of that content. So reusing content is always a good idea on that.
If you ever want to be a level designer, that's literally your job.
Yeah.
Is finding existing content and using it to lay out spaces.
And then this area, I only just spotted this. This almost missed the stream, but I literally stumbled across it while I was flying around just before the stream. There's this lovely area here where they've got some really nice shapes coming together on this. And yeah, like these nice houses, like really, kind of if you again like playing around with this, the forms of all of this, like some really lovely design, like all of these lines, again, kind of just avoiding those harsh straight lines that kind of just take all of the fun out of a space, and all of these kind of areas that are coming in here.
The curves are all very complementary of each other, which is really nice. Like it all reads really well.
So, some really good stuff. The actual game world as a whole is just incredible. Like it's really coming together. So absolutely, kind of props entirely to the entire Titan dev team who are working, just so hard on this stuff for what is essentially, completely optional art jam. The dedication for the people that have been working on this has been absolutely incredible to see. So, keep up the amazing work. We just did a big post of all of the swag earners. Apparently, I caused a lot of people in the Titan Discord to have minor heart attacks. I do apologize for that by atting you repeatedly on the swag channel. But yeah, we've got a load of people earning. I think we're up to over 100 people who've already earned some swag for just generally doing some awesome stuff. So do keep it up. I've talked enough for a minute. So Sam, I think you've got some updates for us on the gameplay character.
Yeah, let me just, if we switch over to my screen for a sec. Here I am in sandbox map. So this is stuff you don't have yet, but we'll have soon, hopefully today. We try not to update just before the live stream in the interest of this working. The big one is customizing your character. So as I'm gonna definitely do some weird things here because that's what we do with custom characters. But yeah, so you can now, there is now a menu for selecting different pieces of the character, turning Lost Fang into whichever character you want as you add character content. You can now have a custom character with UI. So beyond that,
one plug for this. This is a big push for character artists. I'm seeing some absolutely incredible stuff in the Discord channel, but very little submitted to the Perforce
get
server.
it in the game.
So start getting that stuff in the game, even if it's not done. Like we can get it in and you can iterate on it, get it into the project so that we can start playing around. Because I want to change my Lost Fan character to something that other people have made.
Yeah, we'll absolutely review your work if we can. So, get it in the game and we will look at it and you will get to see your work running around with the animation set. You get to play it. You'll get to really get to iterate your character from there. So yeah, this is really fun. If you let me make hideous things, I absolutely will. So don't empower me is what I'm saying. So the other thing that's worth noting is we've done a bunch of changes to walk sliding. I would be showing this in Titan main, but I happen to have another map loaded at the same time and they would be mad at each other. But so things we've added to walk sliding. One, you can strafe in the walk now. So that is based on your speed and also the angle of the terrain that you're on. It's a little bit like snowboarding, so it has a nice curve to it. So all you people who've been building nice walk sliding courses, you should now be able to use the walk to actually steer down using strafe. You can also do camera directed steering. So both work. It's really what you want. They're slightly different. One is terrain based, one is, I believe, camera angle based or maybe velocity based. Sebastian's probably yelling at me in Splat right now. But those are the two big ones. And then the other one we've added, which also doesn't demo especially well on this map, but time of day slider. So if you're in Titan main and you want to see your level at a specific time of day, which you should, slide the slider. It will update the time of day appropriately. It is a tool. It just sits up there. And Sebastian wrote that for us. Thank you, Sebastian. And I think that is all the new tech that I know of coming in this week. There's also been a bit of refinement to the walk on the water, but it is still work in progress because buoyancy is hard. But it's sort of gone from being too wacky to not wacky enough. And we will be continuing to iterate on it for a bit. But that will also go in. So if the walk is weird, we're working on it. So I think, yeah, that's all the tech updates. So we can probably transfer away from my screen now. So there's some surprises for later.
Cool. So with all of that covered, and there's a lot. Yeah, Seva's been working hard in that dev stream. So we will be pushing those changes hopefully today. Like Sam said, we generally try not to do it right before we're about to go live for fear of stuff breaking. So we're going to be covering how the landscape was built for Project Titan. So the main thing is that we have packaged this as part of the project. So if you have access to Titan, you have access to the landscape design tool that we have built. If you are not part of Project Titan and you want to get your hands on it, unfortunately, you will need to wait until the project launches as a fully available sample. But this will be available as part of that as well. So if you want to play around with it, you absolutely can do. So how do we go about building it? Now, there's lots of different ways to design a landscape or create a landscape. The big problem that we have is that our landscape is a bit too big to use some of the more standardized tools that are available in the editor. So there's a plugin called Landmass that is really, really useful for letting you, kind of really edit and iterate on the landscape. In order for us to work, collaboratively, and also to be able to iterate quickly, we decided that the best thing to do would be to build our own landmass equivalent that works at a much larger size. So landmass generally doesn't really work that well past 4K. So that's 4K in terms of texture size. Whenever you're looking at a landscape, you can think of it as a 16-bit height map. So whatever size we're working at is going to be the resolution. We're generally working at 1 pixel per meter. And then alongside that, you also have all of the weight maps as well. So these are grayscale, weights that basically associate which texture you want to apply to the landscape surface. The way that landmass works is that for every landmass blueprint, give you some fairly significant texture memory issues once you get past a certain number. So in order for us to solve that, we basically needed to create a solution that didn't need to do all of that individual layering. So not having individual layering, we needed something that basically just accumulates. And that's how we ended up coming up with this solution. So I've got the example scene here. That's kind of the landscape demo. And the way that this works is that every single element that we add to our scene, so each of these individual layers, basically acts as a single accumulation layer. So I can go in and I can make any edit that I want to this base blueprint. This particular example is a stamp, so it basically just takes a pre-existing height map and applies it to the landscape, and then it lets us basically apply that to this. So I've got one that's set to mask. Say again,
yeah, you keep cutting out. I think we keep losing your voice.
Hold on. It's because I got Titan main open still. Let's try that. Let's just give that a second and not have a 40 gig in memory Unreal project opening all at once. How's that?
That's better. Yeah.
Is that better?
Yeah. Perfect.
Okay. Yeah, there's a lot less memory being used now. Okay. All right. I'll close that. How much did we lose out of interest?
Probably it might be better to sort of start from the 30 seconds ago, 40 seconds ago.
30 seconds ago-ish. Okay, I will do my best. So like I said, we've got the way that we ended up building this is we wanted something where we can put down lots and lots of layers without having the massive memory cost. So the actual Titan main map that we use consists of about 600 layers, I think. Sam, I think about that.
It was, yeah, I think we got it down to that.
At one point we had it at about 800 layers. Because again, like the way that we're kind of like designing that landscape is that we wanted something that was going to work. So, kind of this large 8-kilometer size and still let us edit content. So we ended up with about 800 of these, and we needed it to be something that we could do this with, right? Where we could just move stuff around and actually, kind of like see it all happen live, and not have to worry about this stuff just breaking on us immediately and it's not being able to work.
Yeah, we were both building at the same time pretty much all the time, and
that was the other thing
stopping
we also needed as well. Yeah, is that we needed multiple people to be able to work on this at once. Now, the external actors, kind of functionality makes that reasonably easy for us to do. Each of these individual actors are a standalone file that sits inside version control. So we can check out and work on independent content without necessarily stomping over each other's work. Though, of course, if I go in and I make a stamp that's here and Sam's working on a stamp that's right here, we obviously will end up starting to overlap a little bit. So we did still need to communicate with each other on that content, but the main thing is that we were able to kind of like work in different areas. So the next thing that we needed to make sure that we were able to do is to basically make sure we were able to update the landscape as quickly as possible. So in order for us to do that, we needed to reduce the amount of times we needed to actually update. So if we look at, I'm going to load up our main map, and this might take a little while.
We could, yeah, I can drive around the landscape design.
Have you got it open?
I've got landscape design open. I don't have main
open up landscape design.
Yeah, if we switch to my screen, here we are in landscape design.
You can see what a fully edited landscape looks like.
So each of these is one of those things. So yeah, like this is how the desert was built, was many, many splats all aligned in interesting ways and a lot of iteration.
Yeah. And the thing to keep in mind with this is that, you know, kind of when we're editing these individual stamps, we don't necessarily need to update the entire landscape, right? And that was kind of like one of the key performance savers that we could do for this. So basically what we ended up doing was taking the landscape and splitting it into a bunch of cells. So in this example, the cells are 8 kilometers. So it's an 8 kilometer by 8 kilometer landscape, and we basically chunked the entire landscape into 1 kilometer squares. And then based on the landmass stamp or the landscape stamp that you're editing at that time, it would basically invalidate all of those squares that it was affecting and working on. So if you click on the, I think it's the Splat manager or the stamp manager.
Yeah, let's go all the way up to the top. It's in here somewhere.
Might have been moved out of there. If you just type.
How dare you?
Yeah, just type for manager. It'll be in there.
There we go. Splat manager. So here, let me pull that up.
And then there's a debug of that stamp. So if you go to the details, select it, and then go to invalidation mask, which is one of the textures.
In the Splat manager or in the
manager? Yeah.
Yeah, in the manager, sorry. You can tell I haven't done this in a bit. Let's go back to outliner. My outliner went away, of course. Come back up.
So anyway, what we found was that
there we go.
Actually updating the 8 kilometer texture wasn't too bad, because we're basically making for this landscape, we're basically creating our own render target, which is an 8 kilometer, an 8K by 8K texture, and then we're writing to it. And actually writing to the texture is not that bad, but it was writing to it for every single stamp that was becoming prohibitively expensive. When we were testing, we found that we could do about 100 writes to the texture in construction script, and it not really lose too much in terms of like performance. So when we're moving around that stamp, we're basically invalidating it every single time that it's moved, and we're causing it to redraw. So what we ended up doing was, again, splitting the landscape into chunks, and then writing an invalidation mask, which is that black and white texture that knocks out and basically says, I'm only changing these particular cells at the moment, so only update those particular ones. And what that meant was that we could have, you know, kind of like, again, like Simon could be working on one area, I could be working in another, and we're only ever modifying the height map of the area that we're actually working in. Whereas kind of in the current landmass system, it basically has to evaluate the entire texture every time, and it does it for every single kind of like, and it has its own layer for every single one. We just have one texture. So we have one 8K texture, and all we do is we basically update that every time. And by using that mask, we can basically go, hey, this stamp is only affecting this area, so I can just ignore all of the other areas and rewrite that texture over and over again.
Like if you look at the landscape on my screen and you look at the invalidation mask, you can see that 1-to-1 right there. There it is.
Yeah.
So that is that system working.
Yeah, every time we move those around, and that basically means that every time we need to update a stamp, we only need to iterate through the other stamps that are inside that invalidation square. So basically, every time you move a stamp around, we wipe the area, so that's square. We wipe all of the height map data, and then we redraw it using all of the stamps that are basically going to affect that particular area. And that means that we still get, you know, kind of like a nice. We still have to go through that process of invalidating all of that stuff, because again, it's not like Photoshop. We haven't got each individual layer stored as texture data because it would just be too many. If you imagine trying to store 600 8K texture layers, that's quite a lot of data that you've got to store. So because we're only storing that one texture, we're basically having to redraw it every single time. So by doing this, we're basically able to redraw only the bit that we actually need to edit. And that lets us do that. So
I just have to remember to not save when I leave this, having moved around half the map. But yeah, you can see it updating in real time.
Now, the downside to this is that this height map that you're looking at is completely faked, right? So if you were to press play, don't press play.
I'm not going to press
play. If you were to press play, you would just fall straight through this because actually this landscape is a pure visualization. There's actually no collision data associated with this. So when we are basically changing all of this data, we're writing it to a render target, and then that render target is being fed into world position offset. So one of the things that we found when we were working on this particular element is that actually calling an update to the landscape on a landscape of this size was massively slow. So rather than doing that, we basically created a proxy. So we created this visualizer, which lets us see exactly what we're doing so that we can go in and we can make all of the edits that we need to make. But we can do that quickly. And then once we're happy with the end result, we can go in and we can actually pass that to an actual landscape data. So this map has a landscape mesh that you can see in the scene. And when you click on the Splat Manager, you can press a button called Update Landscape. And this is Sam furiously trying to keep up with me talking.
I'm gonna do it. We're gonna make it happen. I'm not gonna hit that button.
Yeah, you can basically press the Update Landscape button, and it will then go through the standard landmass, kind of setup, and pass the height data that it's calculated straight through to the landscape. And the landscape is then basically updated to match. So you will end up getting parity between your landscape and the landscape visualization for that. And that way, when you press play at that point, you could then play through and actually run around the landscape and see it all working.
You couldn't work at this speed without this system.
Yeah, that was the key thing for us, right? And it's something that we really push on in the art jam. Is iteration is key, right? To building good artwork and to building good design, you have to be able to iterate on something quickly. And that's why we didn't want to go for something that was using an external tool like Gaia or World Machine or anything like that. Because while those tools are great for building a landscape, they're not good for you to be able to iterate on it at the speed that we wanted to iterate on. We wanted to be able to take a stamp, modify it, tweak it, adjust it, and then press play and be able to immediately jump into that world and actually start doing it. So that's why we ended up building our own system rather than using, kind of one of the other systems like Houdini or whatever to design that landscape. So we wanted to be able to do it all on the fly and all live. And that's, again, like one of the big challenges and some of the changes we had to make were to basically let us be able to do this. One of the key ones that we had on that were splines. So if we switch back to my screen for a sec, I've got a quick demo on that for this one.
We had fun with splines.
Yeah, splines are a whole thing. So the way that this worked with landmass was that they did they basically created a shape, and then they do a jump flood, which lets them build out that shape as a gradient. And then they would basically do a jump flood to fill that shape in, and then they would do a distance field generation to basically get the edge of that shape so they could draw it out. That was way too slow for what we needed, especially at the texture resolution that we were working at. So we ended up having to fake a lot of that information instead. So rather than doing that for things where we wanted to draw out a spline, we ended up actually just approximating the spline instead, using some very, very hacky maths So you can kind of see here where it doesn't quite line up properly. So that's the actual spline data that we're using. And then that's the actual line that we get out of it. And the reason that it's doing that at the moment is because we're using very cheap approximations of the actual spline. So we're feeding in the spline point location and tangent, and then approximating the actual shape itself in the material. Now, the reason that this works for us is because while we're tweaking this spline data, we're not actually expecting the spline to be the final output. We're still using the height map data as the final gauge, right? So that's where this kind of system works. But for us, it was so much more important that the system was quick, that we were happy to have some of it be a little bit fudged, right? So we're constantly kind of fighting that particular metric.
Efficiency versus perfection is, again, that's game development right there.
Yeah. So we've got some exposed variables into this as well, so we could do a lot with it. So this is using the linear path as well, so you can kind of see, or not see. Can I not move? There we go. So you can kind of see how it's generating there. If we go in, you can change the different types. So you could use like a bell curve to do it, or you could choose to do an ease where it kind of like ease in and out. So you could very easily and quickly generate like different shapes and different forms. You can change the thickness. And again, like you can do all of that very quickly. And it was really important, again, that we were able to do that with 500 other stamps, all doing different things. And all being able to kind of iterate on that quickly. Same with the material as well. So we have the material option where you could kind of drop down just particular gradient stamps. And it was really important for us that we were able to just drop that down. And again, all of this is all working on one 8 kilometer by 8 kilometer space. We have some questions already. Question: why the landscape is not nanited? Technical reason. So for this, we didn't really need it to be nanite, and also at the time we didn't have nanite tessellation when we were building this because we built it a little while ago. So we probably could go back in now and use nanite displacement and nanite tessellation, but actually it wouldn't really help us for designing the landscape because rendering the triangles is not was not the problematic element. So if I go into the wireframe of this, you can see I actually, again, like because this is not of the actual landscape itself, it's the proxy. What I did was I ended up creating a plane that was, I think these ones are, I think these are a kilometer across. So basically I created a plane that had the right triangle density. So you can see it has all of the triangle density we need. And then I created HLODs that had basically reduced triangle densities across. So we get that kind of like nice high level of resolution when you get close enough to it, but actually we just fall back to the lower resolution when we don't need it. So for us, we were working at the 1 pixel per meter resolution that we needed to work at anyway. And it just wasn't something that we needed. So for us, making it work with nanite would not have given us a particular improvement to the iteration. There were far more other things, there were more important other things that saved us from performance in that point. Do you foresee this custom solution eventually replacing the landmass system, seeing as it's more feasible for large-scale worlds? No, probably not. We built this very much; it's purpose-built for Titan.
It's a bespoke solution for Titan.
It was. You could definitely use it in other situations, but at the moment, this only works at 8K. Right now, you could scale it up a bit, but actually, there's far more sophisticated versions of landscape being developed at the moment by much smarter people than me, who have kind of like proper programming chops and can do it. This solution was built entirely for in Blueprint, and kind of was very much kind of built as like a hey, we need to build this 8 kilometer landscape, but we don't have a very good way of doing that inside the current editor outside of us just going in and hand sculpting it, which would have looked absolutely awful. Which is why we rolled this solution. So it's not intended to be, kind of landmass 2.0 by any stretch. This is just something that, kind of we developed for Titan.
You work with the tools that you have to do the thing you're trying to do at the time,
Question, do those stamps get blended into the overall height map landscape? Yes, they do. You can tell them not to, but they will kind of blend together. So this is one of the stamps that I have at the moment. We've got a bunch of different functionality for this, so you can kind of choose the blend level. Let's go in and let's add a new stamp that's going to do a bit better job of showing this off. So I'm just going to go in and I'll select lerp. So you can kind of see the landscape here. So at the moment, this is set to blend 0, so it won't do any blending at all. It basically replaces the entire square with the height data. But as we increase that value, it's going to start blending it out from the version that we want. So you can now see that it actually does kind of blend in, and you get this kind of interpolation between the original landscape and the new landscape data. So you can kind of see that kind of blends there. And you can do that with all of them as well. So if we do like max, it will try its best to kind of blend in the original kind of landscape with the new approximation for that. So we tended to use, I think we used stamps to build out like 95% of the actual world. Just because they were so quick and they were so nice to do. We could, we could block out using a mesh the actual height that we wanted, and then we could art process that later on, which worked really well. So for the vast majority of the time, the stamps did not look like this. They were actually, we just had the basic forms in. So we would draw out these kind of like basic primitive landmass brushes, and then we would place those down. And then afterwards, I went through and I updated all of the stamps with nicer kind of art versions of all of those.
Just let us pull a bunch of stamps too, because one of the temptations when you're sculpting a landscape is to add unnecessary detail, which I think we both sometimes fell victim to. And so as Aaron updated the stamps, I'm like, oh, I don't need like 40 of these in the desert, so I just took them out. And yeah, so you have to be, that's iteration again. You have to be willing to continually update your work as the core tool set evolves and the tools you're working with evolve.
Yeah, it was quite nice actually, because I think at one point we got to about 800 layers with the
it was taking a while to
stamps
open.
we were using, and then I went through and did an art pass on all of the stamps, and we ended up basically stripping out like 300 of them. So this is the library that we ended up building. Again, this is all going to be part of the Titan project package. So these are 16-bit, kind of height map stamps that I created for this. They're quite high resolution, so they kind of have been designed to be able to scale up, and kind of work with that. And then as part of that, I've also created basically weight and deposit, erosion and other layer information into that as well. So I created all of these different maps, again, using, kind of standard terrain building techniques. And then we can basically use those as paint layer information when we eventually go to paint down all of our weight maps. Out of curiosity, how long did you guys work on this before we had access to it? It's a really good question. I think we were on it for 3 months.
3 months feels about right.
Where we were kind of like building up the base tools, building up the base landscape, planning out, all of how it was all going to work, how we were going to onboard people, how we were going to send out invitations and all of that stuff. So, getting AWS on board and Perforce and getting approval internally to do it as well, because that was another kind of big consideration. Kind of basically going, hey, we want to make a server with 5,000 strangers and let them all create stuff. It was something that we didn't immediately have permission to do.
You froze. We still heard you.
Oh,
We're
okay.
just
Oh,
stuck in a
my
charming
internet's
pose.
clearly not very good today.
But yeah,
Um,
I think, and it's worth saying that while we were getting this stood up, we're also doing other stuff because we have many hats at Epic. So it's like, yeah, but yeah, it was about 3 months of focused work on this thing.
yeah, there
And yeah,
was
the
another
back end
very
was,
minor games industry event called GDC that was happening around the same time as our launch. I think so. We were also prepping a lot of content for that. Sam and I were doing presentations and things like that, and bug fixing and um, looking at other samples and helping out on other projects. So yeah, it was definitely not 3 months dedicated time, but I would say it was about 3 months altogether, kind of
yeah.
getting it built up.
Building Titan's map was my happy place. I would go and
Yeah.
new landscape and be like, oh, nice.
Yeah, it was very fun to work on it and kind of add all the bits together and layer it. And it's also non-destructive as well, which is kind of like another really key part of the project as well, is that kind of being able to go in and have all of these be technically separate layers, even though it is kind of all combined into one, but you can still go in and you can edit any layer in between it and it all still updates, means that kind of if I broke something from one day to another, or or Sam needed to make a change and ended up stomping over some stuff that I'd done, or vice versa, it was really easy for us to go in and just fix those problems and tweak it and know that we hadn't destroyed anything, because all of these stamps, they still have the same data, they still have the same positional information, all of that. So it's very, very safe for us to work on that content. So it was very rare that we would do anything that actually would break anything for anyone in like a truly damaging way. The landscape itself, I think when we started building it, it was iterated on massively, but actually the bones of it got locked in reasonably quickly, right? Like the Arctic region was there, the island was there, the volcano was there, the desert region, kind of got it all
I
got
think
kind
we
of like put into
swapped
place.
Arctic and desert at some point, but otherwise, I think it was all. I
Yeah,
think
we
that was
did. Yeah,
just
I
me
think we did
not
swap.
listening to you and building stuff. But
Um, yeah. How did you? Other question: how did you go from this stamp edit map to the final map? Is there a way that you baked it, or are these stamps just locked in? So we kept the map separate because, again, like with this map, we are still loading in a lot of texture data that we don't necessarily want to keep. All of the stamps are like 2K textures. So there's a lot of extra blueprint information in there. So we didn't want those maps all sitting together. So it's not in Titan main. But we had a landscape design map, and every couple of days or every day or so, we just transfer the landscape data over. So it was, again, really easy to do because we have that landscape button that basically updates the landscape. All you needed to do is to go into the landscape mode, select the landscape that you wanted, and then just export it out. So I can't click on it here because I haven't got a landscape in this one. But you could basically go to the import button, press export, and then export out the landscape. And then you would have it as a file, and then you can just transfer it over to the new map. So every now and then I would do that, just so we had like the most up-to-date version of the landscape in there. But yeah, we kept those two things separate while we were working. And again, like this is why this is a bit of a bespoke solution as well, because you wouldn't necessarily we have a very hard lock from, okay, we're in this phase and we're building the landscape, and then the landscape's locked, and then people are going to build the world. You'd often back and forth between those things a little bit more than we otherwise would. Whereas we've kept the landscape pretty locked down since the game jam started, mainly to give everyone a very consistent base to work from. But yeah, that's kind of like the way that we work. So it's very easy to transfer over. It took 7 button presses, I think, to do it. You press update landscape, file, export, and then you import it in. So yeah, it's pretty quick and easy to do. Next question: is this blueprint C++ or a mix of both? So this is 100% blueprint. And I can show you all of how it works. So we basically have all of our stamps. We have splines, we have mask materials, and then we have the stamp manager. So my brain stopped working. There it is. So if we go and edit this, you can kind of see it's working. So it's the parent actor is just the actor. We have the manager setup. So this is where we go through. The main thing I wanted to do is just reduce down the amount of texture usage as much as possible. So if it detects that there's a landmass brush in the scene, so it's already got the texture data it already needs, it actually just uses that. Otherwise, if there's no landmass brush manager in there, we make our own render target, which is this one here. So we build the render target. We set up some parameter collection logic. We have another couple of textures that we make as well. So we can't do this all on one texture because there's just too much stuff to do. So we build another texture that is 8 pixels by 8 pixels, and that's our invalidation mask. So we use that to basically mask out, kind of that area so that we can only work on one particular one. We have a weight map mask as well that we use to preview our data. And again, that's all using a single 8K texture. And then we also did have to use one other texture as well. So technically, altogether, we're using 3 8K textures. But we're still getting all of those layers and all of that dynamic movement in there as well. So it's still quite a lot of texture memory, but compared to what it could be, it's pretty good. I think, yeah, there's potentially you could probably get away with using just 2. But the way that it writes render targets means that you can't really use the alpha channel particularly effectively. So I ended up using 3 instead. And then the 8 by 8 pixel texture is kind of incidental. I think I can get that one fairly cheaply. So then once we do that, we set up our dynamic materials because, again, this is all faked using world position offset. So we define all of our, where we're getting our height map information from. We define our invalidation mask information. And we set some particular parameters in there. Again, doing all of that again. And then we set up our proxy mesh, which is our hierarchical instance static mesh component. That sets all of the material parameters for that. And then we add the instances. So that basically just makes our 8K proxy mesh for us. And then we have some functions called update render target. This one does it for the entire map, and update render targets does it for the cell-based update. And the way that works is that, so basically anytime our stamp changes, so any of these, once they change, let's go in and edit that so we can see it. And go to our construction script. So again, we're using construction here quite heavily because we need that kind of like constant firing of an update every time we change it or move it around. And basically all of this is going to do is it's going to, inside the invalidate landscape cells, is that it basically figures out where it is in the world and which cell or cells it needs to invalidate. It updates that as an array. And then it sends that data to the Splat manager. So that's basically triggers.
We lost you again. Aaron, we can't hear you. I think your internet is bad.
Clear all of the old data, and then we redraw the new data. So we sort all of our actors, because again, because we haven't got a dedicated layer system, because we don't have individual layers for each individual one, we need a way of sorting all of that data.
Yeah, we lost you for 30 seconds again.
Oh, God. Dang it.
Just that last complicated bit of blueprints that you just
described. Seriously complicated bit of blueprint. Yeah. Okay. It's fine. So the way that I think we probably lost the sort order, right?
Mm-hmm. Yeah.
Okay. So the way that we end up having to, because we have to sort them still, because depending on the order, if you imagine you have a layer that subtracts a load of information, a layer that adds some information, depending on which way you process those, you're going to end up with 2 very different height maps. So the way that we work around that is each individual asset has a tag with a number on it. And depending on the number, it basically pushes the sort order. So basically what we do is we don't necessarily have layers per, we don't necessarily have layers for in each individual item. So there's still some randomness there, but we do allow kind of people to be able to prioritize a layer over another layer. So all you need to do is basically increase that tag or decrease it, and it will process it later or earlier, depending on how you do that. Then we go through, we basically write our weight map information, and then we write all of our height map information after, and that's basically it. So that's how it does all of that. So all it does is it just iterates through all of those, and it gets all of the information that it needs from the actor. So all of these, these blueprints for the containers are mostly just storing information. So kind of the stamp is just storing the height map of the stamp and all of the ways that it needs to process that stamp in order for it to blend in with the original landscape. And then that's it. It will then go through and it will write it. The Spline one is a little bit unique. It triggers an extra process to kind of draw out its shape, but otherwise that's kind of how it all works. So yeah, all blueprint because I don't know. Do we have vertex animated textures set up, or should we make our own? That doesn't sound like it's relevant for this. How the HLODs are built for the project.
People keep asking us to turn on the plugin, basically.
What plugin?
There is a vertex animated texture plugin apparently that I didn't know about either.
Oh, is that for baking skeletal animations?
Yeah.
Okay. Yeah, we can add. If the plugin's enabled in the editor, we can definitely do that.
Yeah, we just haven't done it.
The vertex animation texture material is already enabled. It's part of the base engine, so you don't need it. As long as you've gone through the bake and you've got the textures, you can just run that through the vertex animation texture function that's inside the material editor, and you can add that. Okay, so none of these are to do with the material, so I think we can just move on. Right, we've got the last thing I want to cover on this before we move on is basically weight map data. The weight map was actually one of the hardest ones to solve because it's a pain in the backside mainly. So generally the way that it wants to work is that we have like however many weights we need, we have an 8K texture for each of those weights. That's not practical at 8K, especially for something that we need to be constantly writing to and editing. So instead, we used a single 8K texture and we write a preview. So this is our preview texture that we have here. We actually write our weight data as a separate map, as a separate blueprint. So it does that. It does that after the fact. So you can kind of see here that we get, kind of all of our nice erosion. Kind of like layering on this as I go through. And I've basically got a profile on here that says how I want to paint down this map. So this is my grass layer, this is my rock layer, and I can basically just specify how I want this to paint that particular information into that texture. The Splat Manager has a weight map preview color value, so we can go in and we can set the colors to be whatever we want. Inside our landscape design kind of map, you'll be able to see all of the different landscape layer colors, kind of like showing you all of the values. And then that gives us our information. Now, sorry, the downside to that is that it's only a preview, so it's not actually really usable as weight data in its preview state. So what we do instead is we have an export option, which will basically run through each of the individual weights and reprocesses the entire landscape for each individual one. Now, that's quite a an expensive process to do, so it's not something that you can do on the like live. You have to let it process. It takes a couple of seconds to do, but it does mean that we export out each individual weight layer. So the way that it will work is that it will set the desired weight that it wants to render, and it will run through the entire map and re-render the entire thing, but with its weight. And then it does that however many times it needs to for the weight data. So for this map that we, for the, Sam, I think have you got up landscape design still?
Yeah, I do. We can switch over.
Yeah, if we switch over, my throat doesn't die. So if you go to the Splat Manager and go to the weight map preview color and expand that out, you'll be able to see all the different weight maps that we have. Again, the way that you tend to build at an 8-kilometer scale, we've gone quite exaggerated. So we have lots of different biomes and lots of different regions, but you could have a lot of different landscape paint layers on your final landscape, and we needed to be able to represent all of those. So we have, I think it's like 20, I think, or something like that.
18.
We have 18 individual layers that affect different, kind of different things like ice and grass and volcanic ash and, kind of all different elements and pieces. And basically, because we're just previewing, we can do that really quickly on a single texture. But as soon as we need to go through, we have to actually go through each of those individual weights and re-render each individual weight map. Like I said, it only takes, I think it's like 7 or 8 seconds to actually run through and export all of those things. And then once we have them, we can then import them into our final map and render them out. So you can see this is why this isn't like a fully fleshed out feature of the engine. This is a hack in order for us to build, but the added benefit is that it's super quick for us to do. So if you take one of the Arctic weight stamps, so that's the one that's got the dragon head on it, and move that to like the middle of the map where it's in like grassland or something, you can see how it's kind of going to update. You might also need to go into tag and just increase the the priority on it. So if you set that to like 20 or something. So again, like, because the weights are, again, they have a process order that they run through. Yeah, what's that on at the moment? I can't see.
Yeah, I mean, neither. It's deciding to be difficult. There we go. Come on.
I really need to expose that option as a button. So
yeah, it would be so nice.
You just type in tag, it'll...
Yeah, it did that, and then it didn't want to show me the weights, of course.
No?
Somewhere in there, we have... I think I actually selected the water, that's why.
Oh, okay. Yeah, that would...
There we go. There is a weight tag. So if we scroll down to tags, 12, 13.
Yeah, so just increase it so it has priority over everything else. And then as you move that around, you'll see that all of this, the weight maps paint information is completely localized to that thing. So you'll be able to move it around and change it. And again, like we did originally have it so that every single stamp had weight paint information that you could set on it. So the original way that we had this was that it would basically go through each individual layer, so all 800 layers that we had in there, and it would do a weight map process for each individual one, and each stamp had a number of weight layers that you could apply to it. So you could put down like a height layer that would give you a gradient on its height. You could add an angle layer that let you apply it based on a surface. You could do loads of different things. And we found that actually that just made it incredibly slow, right? Because now instead of it doing 800 passes on each individual layer, it was now doing 800 times the number of weight stamps that each individual thing had on top of it. So we were getting up to like, basically it was like 3,000 different processes that it was running through. So instead, we moved all of the weight map data to a separate standalone element, and you could basically position those and move them. And that gave us way, way more control over where you put the layers. It also meant you could move it around much more easily. And it was just generally a much better idea. So I don't know why we didn't do that to start with, but hey, that's why you iterate on this stuff.
Yeah,
so yeah, you can see that now Sam can put down some snow in that region really quickly and easily, and we can kind of move all of that content around without kind of having to do too much work on it to get it to work. And while you show that, I'm going to open up the next map.
Okay, so I can talk for 5 to 6 minutes while we're opening up the next map. And so, while you're doing that, I could talk a little bit about landscape design from a design perspective. Just, I'll vamp. Especially since Aaron seems to have frozen, I'm just going to go, I've frozen too, also.
Not again.
Maybe not. Okay, so one of the things to think about when you're laying out a world this big is, and this is something we've addressed a bit sort of in feedback, is you lose sense of scale. Because I look it up like this, I'm going to do it in detail lighting mode, which is how I like to look at things. And then it's like a toy town, you don't think, oh, when I'm actually playing the game, I'm all the way down here and I'm like about as big as the bottom third of the screen. So it's one of those things that we had to kind of tackle where I realized I was not building to player scale. I was building to God's eye view. So again, play testing your stuff is really valuable. That's how you end up with sort of sections like this, which were built to be traversed in interesting ways versus, oh, I have a huge bowl that looks cool from space, but is not actually that interesting when I'm playing it. So as with everything, like there was a lot of play testing involved here, especially as we were building out the movement mechanics for Lost Fang in terms of the grappling hook and the walk and everything. Like, oh, we need to be able to slide down stuff. We need to have water and rivers to go down. We need to have height variance for the grappling hook to be valuable. And so we did a lot to iterate the landscape to sort of factor that in. The landscape got a lot taller. At some point, we made it 1.5 times taller just to see what would happen and realized it looked way better like that. We kind of stuck with it. That's game development. How are you doing? Are you open yet, or
no, I'm open. It was a small project, so it's not too bad. But yeah, so I wanted to, because again, like it's one thing to talk about kind of how we design the landscape. I think I'd like to do it's worth talking a little bit about how our Titan developers can really start pushing the landscape a bit more. Now, obviously, we have the landscape locked just to kind of make sure that everyone has a consistent playing field to work on, both literally and figuratively. But that doesn't mean you can't start adding to the landscape as well by adding some materials to it. So we have, like we showed earlier, we've added 18 different layers for the landscape. We can absolutely add more, and that's not a problem. But what is going to be great to start seeing is people building materials for the landscape. And to do that, I have built two to kind of demonstrate the general principles about going about doing that. If people want, we can build a standard material base that people can work on. But this is our base one. So one of the really nice things about 5.4 is that we have nanite level of tessellation on geometry, which means that we can do really cool stuff like this, where we have like actual displacement on our landscape surface, and it's like seriously high polygon count on this stuff as well. So I can go in. Let's do quick nanite ungodly triangles mode, and we can kind of see all of the different triangles that we have on there. So this is really nice because for our super high-end players, our super kind of high-end platforms, we can enable this, and we can have they get to have like nanite levels of displacement, but it's really easy for us to also just turn this off and remove it and have non-nanite geometry in. So let's see if we do our nanite set to 0, we can turn it off and we still get the same base shape. We still have the same collision to work with. It just doesn't look quite as good. So it's really nice and easy for us to scale this. And again, we've implemented this on a lot of our textures on our shaders as well. So hopefully this isn't new to anyone who's in the on the Namite dev team who are building away their assets. So I'll just talk through quickly. These are the very quick and dirty textures that I made, unintended because it is dirt. I'm on fire today with these. And let's just turn off grass so that we can actually see these well. So the main thing that you need to consider when you're building landscape, kind of grass or landscape layers, is you need to make sure that these work at scale. So one of the things that's really, really easy to spot when you put, when you're building textures is that you generally need to build these reasonably small. So, the textures will represent 1 meter or 2 meters of texture space. And you need to do that in order to get, good texel density on the texture. But that becomes immediately obvious that it's tiling once you start scaling it out. So the way that you generally will get around doing this is that one, you can break up the texture by blending in lots of other textures together. You can create variation across the texture in other ways by using shifts in hue or masking in order to do it. Or you can use, I think it's got a particular name in the engine, but generically it's like a spatter texture, which is where you can kind of you can basically blend the same texture but rotated and scaled in different ways so that you can basically break up the variation. That's quite an expensive way of doing it, and it's generally effective on breaking up small levels of information, but it doesn't necessarily help you at like a bigger distance as much. At that point, you're much better off kind of like breaking it up with more texture data. So the way that these are built are in a tool called Substance Designer. If you haven't used Substance Designer before, it's a really nice way of building up textures procedurally. So these are the ones that I've created here. Again, one of the things that you should keep in mind when you're building textures is noise. Now, noise has lots and lots of different references when we're talking about it. In this instance, I'm talking about noise as texture noise, so texture information. The easiest way to kind of visualize this is if we take a texture here and I go in and I'm going to let's add a really garish shape onto this. So I'm going to add like a small disk, like so. And let's also transform this at times so that we get some good representation. So if we look at this texture here, this has reasonably low, or it has reasonably even noise information. So the texture is reasonably consistent across the entire surface. If you were to look at this across like a histogram, it would be relatively consistent across the entire texture. But if you introduce something like kind of like a very small but very, very distinct texture element on top of that, so in this instance, I'm going to add this shape into here. So let's run it through a gradient map and then blend it in. In fact, I don't even need to do that. I can just do this, and then add like a uniform color. And add that on top of there. And let's make this like orange or something like that. So now we've got this like orange spot on our texture, right? So you can immediately see that orange spot, and it becomes really obvious that the texture is tiling. Now, this is a pretty over-the-top example of this, but it's still pretty distinct. So if we make this texture really small, and we create kind of basically this is like a point of interest on the texture. And what it does is it makes the texture really obvious where it tiles. So you can kind of see that once it goes in. Now, what you want to do is where you're creating these textures that are going to be used across a very large stretch of environment is that you want to try and avoid those points of interest as much as possible. This is something that's quite difficult for some artists to do because they're very used to creating unique texture space. So they'll go in and they'll they'll bake out kind of like a map from a high poly to a low poly, and then they will uniquely texture the entire surface, and that means that they can have like these very nice unique pops of texture information on the surface. But actually, when you're creating stuff for a landscape, when you're creating it for this information, it needs to be as kind of almost generic as possible in order for you to break up the look of the tile on that surface. So with this particular texture, I've tried to create as little variation as possible while still making it interesting and giving me some good textural information on here. The rocks are a key part of that, right? So on this particular texture here, you can kind of see that I've got these little pebbles scattered through the scene. I've created a tile sampler on here, so I should be able to change my mask information on this pretty easily. So as we kind of create more and more, you can kind of see how much that changes. So you can see once you get to a certain level, you create these square identifiers where you can really easily see, kind of that texture breakup on there. So it's really important to try and find that nice middle ground where you've got enough variation on the texture that it's interesting, but not too much that it creates a really obvious texture, kind of tile on that surface. So try to break up that as much as possible when you're building those. So when you're building your materials, think about it in that way as well. Make sure that it's got enough surface variation at scale that it's going to look, kind of good still. So yeah, hopefully those help. I will submit these to the Titan server so you have access to them. We'll also do a breakdown video on Titan Discord as well. So don't worry about those. We'll pop those up a bit later on. We've got time for a few more questions, I think. We've got a couple of minutes left, and then we can wrap up. Next question we have, can we get a little explanation of how HLODs are built for the project? That is a great question. So we have, and we can kind of tackle it from a few different ways. Now, do I dare attempt to open Titan main on the stream? I'm going to do it, and we'll lead that, and we'll talk about it. So we have world partition inside the editor, which has a way. Basically, it's the way of breaking up the world into chunks, and we can choose how we build proxies of those chunks inside our world settings. So we have gone for a very, very simplistic way of doing those chunks. So we have our maps segmented into 25600, I think, squares. And when we chunk those squares, we basically say, take this square and then build a voxelized version of all of the meshes that we want to in that scene, and then give me a low poly kind of version of that asset that I can then use. So that's how world partition works, is that we can basically choose how to do it. We have lots of different other ways of building. So you can also choose instancing as well, which takes all of the actors, the individual actors inside that cell, and it batches them all together into instances. This is really useful if you're having to put down a lot of individual actors. Like, let's say you've got like a tree, but you want to be able to chop that tree down. So you want to be able, it needs to be inside a blueprint so that you can interact with it. But obviously you don't want to have individual actors for every single tree inside your forest. So you use world partition to basically take all of those trees that are inside blueprint and convert them to instances in that batch. And that means that when you get close enough to it, it'll convert it over to its blueprint version. So you can go in and you can hit it and chop it down. But on distance, it's going to revert to its instance batched version. And then further back, it might get converted to its voxelized, kind of proxy mesh representation. And all of that is set up inside the world settings with HLOD rules, basically HLOD rules that dictate what distance should we fall back to this version of it. And then when we build our game map, which none of you should do on the project because it will take a very long time, and we have an automated backend builder that we are still tweaking and getting right. but it will basically build all of those HLODs. So it will go through and it will voxelize all of that geometry. Now, there's lots and lots of ways of editing how it voxelizes that, and you can actually set up lots of different layers. So again, trees are a really good example of this. You may not necessarily want to have it voxelize all your trees because it tends to do a bad job on the kind of geometry you end up building when you make a tree. So at that point, you can actually shift actors into different HLOD rules. So you can say, for these assets, I want them to be on one HLOD layer and process the HLODs in this way. And then for another asset, I want to do it in a completely different way. The landscape is a really good example of this. The landscape has its completely own HLOD rule generation set, which is inside the landscape actor setting. You can basically specify how it generates that. So those are always different from the actual meshes that we place in the scene. And you can also tell actors to just completely ignore HLOD and just not be there at all. So this is great for anything that's really, really small. So for any small assets, you might want to say, just don't bother. Don't be included in the HLOD at all. Strip out and then don't worry about it. And that way it's just going to not render at all. It's just going to unload. And then when you get close enough to it, it will load in. And then in the terms of kind of like all of our extra stuff that we have a thing called HORDE, HORDE, which will automatically run through a bunch of stuff for us. We can actually tell HORDE to do a ton of stuff. But in this instance, we tell HORDE, which is basically an automatic computer that we have running on a server. It will go in and it will run that build process for us and then submit the end HLOD results. So this is really useful. They're super cheap to run. So we, again, are partners at AWS. We have a HORDE server running on our AWS system. It costs us about $7 a day to run, and we could actually shut it down if we didn't need it to run as well. But basically every night it goes through to the Titan main map, it runs the HLOD build process, and then it submits the end results, assuming that there isn't an error stopping it from building. So that's a really nice way. If you've got a kind of a reasonable team size, and you're building a large map and you're having to dedicate people's time to building HLODs, it's well worth looking into getting a HORDE server set up that will automatically build that stuff for you. And all of that stuff's gotten much, much easier to do over the last couple of versions of the editor. There's the DevOps team at Epic are incredible and have been building some amazing tech to make basically people like us lives easier, so we don't have to worry about this stuff. How do you earn swag? So you earn swag in a number of different ways. If we see cool stuff in the map, we will give you swag. And when we see more stuff get added, we will give you more swag. We accumulate swag throughout the project, and then at the end of the project, we're going to send it all out. We may try to send it out a little bit earlier if we can, but we will see how many people we need to send swag out to and how well that goes. You can also earn swag by generally just being an amazing person on the Discord. So Clucool, who's one of our moderators, is already up to, I think, like they've earned all the swag you could possibly get at this point. But they've basically been on the one of our moderators and have done just a tremendous amount of help getting people through perforce problems and all sorts. So as well as contributing assets to the project as well. So the way that you generally earn swag is by making cool stuff, but you can also earn it by generally just being a very helpful person as well. So be a good team player, kind of help out people where you can, kind of be a good collaborator on this stuff, build cool stuff, and then we will reward it with swag when we see it. And if you see anyone who hasn't earned swag who you think should be, you can let us know as well. Do you do PCG stamps with this? No, I think you're talking about the landscape tool there, but we are looking at converting it over to PCG because there's tons of stuff that make PCG make it a much better candidate for that. So we are looking at doing it through PCG instead, but at the moment, no, it's all done through Blueprint and Construction Script. So pretty old school way of doing it at this point. Nanite Landscape versus POM. Would Nanite have considerable performance decrease over POM? I haven't done any side-by-side testing, so I'm not 100% sure. So nanite tessellation will look significantly better than POM. For anyone that doesn't know, POM stands for parallax occlusion mapping and is basically a way of faking height information on a surface. And it does that by basically rendering the geometry or rendering the shader at basically its set heights. So it kind of goes through and it kind of renders it at different heights. That looks really good from certain angles, but as you get, so if your player view is here and your surface is here, as your player gets closer and closer to like the glancing angle of the surface, you'll see, kind of basically the stripping on that surface as it's trying to fake that height. So parallax occlusion mapping, it might be cheaper, but it has lots and lots of downsides as well. So it doesn't look as good from different angles. It's still a very expensive shader to run. And it's also not very good at blending between different parallax occlusion mapped textures as well. So if you have ever tried to blend between two different POM'd textures, if that's a word, it's very, very difficult to get that to look good. Whereas the nanite displacement has a really nice way of, it blends really nicely together because you're just blending height map information. It has a much nicer way of doing it. So it might be more expensive. Nanite tessellation is expensive. It's not, it's not just like a free extra you get because you're using nanite. It has got extra costs to it, but it has significant advantages, significant quality benefits to it as well, and it's very easy for us to turn it on and off. So what I would say is just build for nanite tessellation in mind. So with the base material, make sure that you're putting your height map in the alpha channel of the surface texture, because that all gets processed by our material. And then we can always turn it off if we can't afford it. It's very easy for us to do that. So I would use that over POM for the most part. How long have we got? We've got a couple of minutes and then we can wrap up. When we extend the functionality of the main material, do we need to get approval before we commit the material into the project for others to use? No, you don't. But if you've done something bad, we will find you and we will point it out. And that's absolutely fine.
That is my dog barking in the background. And he will find you and he will bark.
Yeah, the dog will send Sam's dog to come and bark at you. So no, you can absolutely expand on it. What I would say is to try and make it generic so that other people can instance off of it and implement it in their own way. Make sure you're thinking about the hierarchy of instancing when you're building. So it should look very tree-based. You should have a base material or a couple of base materials, and then those should instance off into logical, kind of children. And then of those should instance off of as well. So always try and think about the tree hierarchy when you're building. If you end up with a very flat hierarchy, it makes it very difficult to propagate changes up that tree. So make sure you're considering that when you're building. Try and use the base material function that we've provided where possible. But otherwise, yeah, it's one of those things where you can definitely go in and build your own, kind of materials on top of that. We don't really want to stop people from doing it. We've got a whole section called materials in the challenge, right? So we expect people to do some cool, awesome stuff in there. And please do feel free to do that. But do keep all of that other stuff in mind when you're building. Don't just arbitrarily go in and build a material that does exactly the same stuff as the base material does, right? If you are going to build a material, make sure that it has a unique quality to it that makes it distinct from all of the other materials that are out there. And we don't want duplication. So if you are going to build a material, make sure that it doesn't already exist. Make sure that you let the group or the region know, make sure the material team know that you want to build this thing in case someone else is already working on it or has already built it, and you just didn't spot it inside the mass of assets that we have
amount of content
inside Titan.
Use the naming conventions. We have a document with naming conventions. Name your materials properly, name your textures properly, all of that. Please, it will make everyone's lives easier. Lives. I can't even speak words anymore. And also, when you are naming, say, your variables and your functions and so on, name those in a way that people understand what they do. Because if other people are going to use your stuff, which they probably will, it helps if you look at it and go, oh, that checkbox does this, versus checkbox 1, checkbox 2, checkbox 3.
Yeah.
So think about the users.
Yeah. Last question that we have. This is a good one. Do you know how many batches of participants are left to be accepted, or do you know when you are finishing accepting all participants? So we, the way that we have ran this, and we've tried to say this on as many occasions as possible. So, but we basically we add new challenges every Monday, and the challenges that are added are all of the people who signed up since that last Monday when we added people. So at the moment, we're on Friday. So everyone that registered from Monday to now is in a batch, and we will add all the people from Saturday and Sunday into that batch, and then all of the people who we get on Monday as well. So that is one batch. So everyone who applies to the challenge that week is batched together, and then we send out the invites on Monday for all of those people. There's no, we don't have like a bucket of people left outside of that. Every single group is per week. And then we have all of the people who joined at the start of the challenge who we did as one massive batch. So we added about 3,000 people, I think it was 3,500 when the challenge launched. And then from that point on, it was added weekly for every single other group. So the challenge submission does close this Monday coming, as far as I'm aware. If you go onto the ArtStation website, and go to the challenge section, there is a deadline of, I think it's April 29th is the deadline. So basically you have until, I mean, I wouldn't even, don't join on Monday and expect to get in at that point. Try and, if you want to join this challenge, join it now, don't wait, so that you're inside the last bucket that's going through. And then April 29th is the last day where we will have accepted people. So anyone that's in that bucket will get added in. If you have signed up to the challenge and it has confirmed that you've gone through and you haven't received an email, there are two things you need to do. First, check your spam. We've had a load of people get quite indignant at us that they haven't received an email, only to find that it was in their spam folder. We have also had a lot of people get quite indignant about us not sending the email out, and it's been sent to, they've been checking the wrong email as well. So make sure that you are actually checking the email you signed up to ArtStation with, because that is the email that we will send that out to. If an email doesn't get sent correctly, if it bounces back, we do know that, and we do reach out to those people whose emails have bounced back to them. So if you haven't received an email, or you think you haven't received an email, and it hasn't bounced back, then it almost certainly has sent, and it's almost certainly delivered to your email address. So check your spam folder and whichever methods you have for spam filtering. Check that your email address is the one that matches your ArtStation account. And if you have done both of those things and it's definitely not those, check your ArtStation messages. And if there's no ArtStation message, then reach out to ArtStation support. You have to go through the ArtStation submission process to join the challenge. We have a lot of legal terms and conditions that you have to agree to in order to join this, because we are going to be publishing all of this work at the end. So you have to join through that means. You will not be given, we can't give you an email or a login directly. you have to join through the ArtStation process and go through that setup and link your Epic account and so on to join. So go through that process. You have until the 28th to do it. So get your requests to join in now. And if you haven't, and you're 100% sure that you didn't receive the email, then you can contact ArtStation support for some help.
Yeah, there's not really much we can do at that point. Go to
Outside of that, there's nothing we can do. Yeah, we get given, you know, we get given the very, very filtered ArtStation application information. So basically, we only get the information we need to create the Perforce account, and that is it. So we, in terms of being, you know, kind of compliant for data protection, Epic is insanely strict on that stuff. So we do not get any more information than we have in order to be able to create an account for you. And that information is your username and a generic password that we then send back to ArtStation. So it is incredibly locked down. So we can't add you. We can't do any of that. You have to go through the set process, unfortunately. But that's the way it works. Right, I've managed to talk about that for like 6 minutes. That's impressive. So anyway, that's all we have time for this stream. We hope that that was useful and insightful. If you would like to play around with the landscape design tools, they are still being developed, so they're not the version that we're going to ship with for Project Titan, but you are welcome to play around with them. It's still in development, so they are super finicky. But if you the best way to do it is make a new level, drop the Splat manager in, and then start adding the extra blueprints in after that. It's probably the easiest way to just play with it. But otherwise, that's all we have time for. Thank you, Sam, for joining me again. All of the people squirreled away in the back end, making sure that this live stream works. Thank you. And the Titan devs who are working on all of the content that we get to sit there and just look at and marvel at. Thank you so much for all of the stuff that you're doing. It's just awesome to see this content added. The last thing I will say is make sure you are submitting your content to the Titan server. It doesn't get included unless you add it. It also makes it much easier for us to help you and give you critique. If you don't add it to the project, we can't see it very well. So
don't be afraid of critique. Critique is nice.
And don't be afraid of critique. And also, make sure you are updating your ArtStation submission page as well. While it doesn't have a link to the project or the swag, it's part of your portfolio. So make sure that you are keeping that up to date as well to keep your portfolio active. And it's all good practice from that point of view. Thank you so much for joining, and we will see you next week.
Bye, everybody.